So what is component interaction? So component interaction will assign a global interaction between all the parts. So there are three types of global interaction. First one is bonded, second one is contact, and third one is free. I'll just show you what are those. So these are the three types of contacts or interactions. For let's start with bonded. Bonded entities will behave like a welded part. It let's say two plates are joined over here. Uh, they they won't lose contact to each other. They will be they again they will behave like as if they are welded. Next one is contact. So you can see in this video, it will it can be it can come into the contact with the another plate, but it won't penetrate that plate. It is called as contact. We mostly go for bonded or contact type of interaction. So free interaction is nothing but, let's say these two plates are given interaction as a free. So one plate can easily penetrate the other, and the results we get will not be as much as accurate. So we always go for bonded or contact mesh, contact interaction. But sometimes, let's say I know for sure, I'm quite sure like two plates won't come in contact at all. So I can apply the free type of component interaction between them just to reduce the simulation time. So for free type of connection component interaction, the simulation runtime will be much more smaller. So moving on to simulation. Yeah, moving on to the simulation. When we when any assembly is opened in SolidWorks simulation, it will give the global interaction to all of the parts which are showcased over here. You don't need to. I won't say you don't need to. All you have to do, let's say, all of your parts are bonded or welded together. So you don't need to add any other interaction over here. But let's say some of your parts have contact or they are not welded together. So you have to add a uh, contact interaction between them. So for that, we'll just suppress this global interaction since all of the parts are acting as they are not welded together. They are not welded together. So for that, I'll just right click on connections. I'll go to the local interactions. For this, I'll keep keep the type of interaction as contact interaction. And let's say there are multiple parts. There are multiple faces interacting with each other. So you don't it will take a lot of time to add it manually. So we have one more feature to automatically find local interactions. All you have to do is click over here, select the component or assembly. I'm just selecting it from design tree and find local interactions. So you can see the SolidWorks has added multiple local interactions over here. For that, to add this these interactions into the simulation part, you have to select all the interactions and say create local interaction. Keep that in mind. The type of interaction should be contact. Not only that, you can also add coefficient of friction from over here. Let's say I'm adding it as, I'll just keep it as 0.05, and I'll create local interaction. Yes. Now this this pin will give us some problems, since it is small part. The the elements after creating mesh will be smaller. It will take more time to compute or complete the simulation. So for that, we also have pin interactions. So SolidWorks does this thing. You can simulate or you can add a virtual pin instead of using your CAD model. All you have to do is go to the parts, and let's say now we're gonna use the virtual pin over here. So for that, I want to remove this part from the assembly, or for simulation only, but I want to keep it in model. All you have to do is go to the design tree, right click on the part which you want to remove from the simulation, and navigate to exclude from analysis and click on it. So it will just remove that part from the analysis. And whenever you exclude any part from the simulation, it will automatically suppress its interaction between other parts. So after this, I'll just add a pin connector. So not only we can add virtual pin, we can add spring, different types of bolts, counter bore, standard screw, or everything else we can add easily. Also, we can simulate welding conditions. We can add bearings, and there are other constraint over here. So we'll just for this we just adding a pin. For that, it will ask you, the SolidWorks software will ask you to select two faces where pin should be located. So I'll just select these two faces. After this, it will ask you to add its strength data. If you are using a part from SolidWorks toolbox library, it will automatically convert its strength data, and it will just put it over here. For this, you for this we'll just keep the strength data as it is. We won't add anything, but we will just add the rotational stiffness to the pin. Let's say we're gonna give pi Newton meter per radian. So after clicking on OK, it will create a virtual pin over here. So virtual pin is, there's no meshing required for the virtual pin. So it will take much more less time to simulate the condition. So after this, I'll just yeah. One more thing. Since uh, to constrain these two parts, parts correctly, we have to add a bonded interaction between these two faces, like this face and the bottom face of the plier. And let's say you have added all the interaction, but you're not sure you're right. All you have to do is go to under constraint bodies, click on it, and say calculate. So it will quickly calculate all the unconstrained bodies for you. So for this, it is fully constrained. Just click on OK. We'll create a mesh. for the same, keeping blended again. This is one of the this is one of most important step in my opinion, since sometime it will give you accurate minimum element size. Let's say for now it's right, but when we are in bigger assembly, it will automatically take around 1 or 2 minimum element size. But when we calculate the minimum element size from here, it will give you around 4 to 5 So after calculating, just say apply, and it will save you a lot of time. Like I was working with the customer and I've done the same. It used to take me around half an hour to simulate the same before this applying this uh, applying this method in my simulation. But after adding this, it was taking around 15 minutes. So it is massive difference. So I'll just click on OK and we'll just create the mesh for it. You can see wherever we have applied the fillet, there's a refinement of mesh. So again, software does it on its own. The solver will does it on its own. You don't have to interfere. Just let's say you're not satisfied with this mesh, you have to refine it much more. Only after that you have to use mesh control parameter. Other than everything is fine. We'll just say run this simulation study. And again, one more thing. There is no mesh created for the pin. Again, it's a virtual pin. If we add the pin connector or the actual pin, it will create a mesh for it as well. And again, there are when solver generates the mesh, let's say uh, we have two components. Yeah, it's solve the mesh or solve the study. I'll just uh, let's say we have added a contact type of interaction between them. So solver will create a uh, two different mesh for these two parts. But let's say we have added a bonded interaction between them. Then solver will consider this as a single entity, and it will create a single mesh for the whole model the the part we which is created. Yeah. We'll just check the results. Yeah, you can see the maximum. Again, you have to edit it from here, your units. And let's say you want it in one go, you don't want to change your units over and over. All you have to do is, sorry, over here, go to simulation tab, go to options, go to default options, and it will ask you to change your units. So uh, all you have to do is like change your units according to your standards. So for this, for temperature, I'm gonna use Celsius. For angular velocity, I'll keep it as radian per second, and for pressure stress, I'm gonna keep it as MPa. So I'll just click on OK, and I'll rerun the study. And again, let's say you have changed the material for the part, or you have changed the forces or anything else. You don't need to mesh it once more. All you have to do is hit the run this study button, and it will give you the results. You don't have to create the mesh over and over again. Yeah. So it's there. You can see the strain is in MPa. You can see the concentrated area for stress and stress is over here, is on the fillet. you can, let's say you want to hide this part, and I wanna just see. I just want to see this part. I'll just go to edit definition. I'll showcase minimum annotation, minimum and maximum. Like where is the minimum stress or stress generated? You can see it from here. Also, there are multiple settings over here. Show hidden body or show excluded bodies. You can do this from here. So these are multiple types of settings over here. And let's say you don't want to use this type of numbering system. It's a scientific numbering system. You have to use a general kind of. You can change it from here. For this, we're gonna keep it as scientific, cause yeah. So you can check it from here. I've hide that part to showcase you. See, there's a little bit light shading over here. So this is where the plate comes in contact with the pliers. So in this way, you can set up the study when there are multiple types of interaction or there are multiple parts. So after this, we'll move on to shell modeling. Shell modeling is nothing but converting a solid part to a singular surface. So let's say you are using multiple sheet metal parts in your assembly, and you keeping those parts as solid. So it will take much more time to simulate all those parts. Instead of that, you can use those parts as a or you can convert those parts into a shell entity and give the thickness to it. Let's say there's a sheet metal part in my assembly. It's of 2 mm, so I'll give thickness of 2 mm to the surface. So solver will automatically create a 2 mm thickness around that surface and will simulate it. So why do we use shell surfaces or shell model? So it will save your time for simulation, and it will give you more accurate results for this for the simulation. So let's move on to that. We'll just open the same study once more, the rectangular hole part. For this, I'll just create a new study, say okay, and you can change define shell by selected faces to apply to apply convert this part into the shell part. All you have to do is select a face and give the appropriate shell thickness. And I'm keeping the part as thin shelled. So there are multiple types over here: thin shelled, thick shelled, and composite. We know what is thin shelled. Composite is again when when you want to simulate the conditions for composite part, and let's say there are different type of layups in a single part. So you can define those from here, but it's only available in SolidWorks Simulation Premium portfolio. Again, so we'll stick with the thin shell part. We'll stick with the static simulation. Again, we're gonna cover all these parts in this series of SolidWorks Simulation. Yeah, sorry, we have to change the thickness. I'll just check its length is 10 mm. I'll just edit definition from here. Again, change it to 10 mm, say okay. So it will now show you the preview of the model, but it's not accurate. So you have to change its offset. So all you have to do is go here and change it according to you, since this is not also right. Yeah. Uh, yeah, just a minute, Adesh. Yeah, Adesh, you can unmute yourself.
Hi, Adesh here. I just wanted to know. Actually, I have asked you two questions. One is that repeat mesh parameter ka how to select that multiple options, and the recent one shell creation. Hello, am I audible?
Yeah. So to you want to repeat the mesh parameter. Okay, I'll just uh
And this one also, yeah.
yeah. Can you specifically tell me
No,
what you
no. You
want to
see,
know?
I have asked you two questions. One question was old one actually. That I need to see the mesh parameters again. That is old question. And latest one is that how you have started for the
Yeah,
shell
yeah, yeah.
preparation. Yeah.
Okay. So there are two ways to define the shell for the
Mm.
part.
Okay.
First one is you select the part, right click on it, and apply or select the
Depends on-
part define shell by selected faces. So
Okay.
after
Okay.
this, you just have to select a face for it. I'll just delete this. Yeah, now this is a again this is a 3D part. It's a not surface part. So
Mm-hmm.
I'll just again define shell by selected faces. I'll click on this part. I'll give the thickness of the actual part. This part is of 10 mm, so I'll just give the thickness of 10 mm. For this, again, I have to select offset to match the actual thickness of the part. So this offset simulate accurately for our problem. So in this way, you can add a shell definition. And another way is like I'll just delete this. Yeah, all you have to do is go to the model, say convert to sheet metal, select a face. It will so this is now a sheet metal part. So
Right.
after you open or you create a new study, it will automatically take it as a shell part. So you can see whenever we use sheet metal part, it will show this icon over here. And you can when you hover it, it will give you thickness and the type of shell we have created. So it's of 10 mm a thin shell part. So in this way you can create the shell part for the simulation. Do you have any
Yes, yes,
another
yes.
question? Yeah.
No, no, no. Thank you. Thank you. Thank you.
uh Prathamesh.
Yes, training.
Yeah, just whenever someone asks me something, just let me know. Guys, please raise your hand if you have any question regarding this.
Sure, sure.
Yeah, I'll just continue. Uh, uh, yeah, I converted the part into the shell model. So I don't have to define the shell, but let's say I want to change the shell thickness or there are multiple shelled parts in the model. So you have to manage all those parts in a single place. All you have to do is go to shell manager. It will list all the shelled elements or shell parts over here. From from here, you can easily change its parameter. Let's say you want to change its thickness. You want to change the type of shell. All the other things you can do it from here. So since this is a normal part, you don't have to go to shell manager and change it again. I'll apply the material, keeping it as alloy steel. Yeah. Again, fixtures. I'll keep the fixtures as it is, like I've shown you previously. Uh, for again, I'm gonna keep the mesh as blended curvature. See, software has taken around 5.9 mm, 5.98 for minimum element size, and uh, after calculating it, a solver says you can work with 15.3 mm element size. So for now, I'm gonna keep it 5.9 since uh, it is not taking much time, like it's taking 5 to 10 seconds. So I'll keep the mesh at as it is. I'll just click on OK. It will mesh. Now you can see there is no solid part. It will showcase the part as a thin shelled or surface geometry. So in this way, it will a solver will sim create the shell, and after this, after that, we just have to run it. Yeah, and you can again check your results from here. So let me tell you something about mesh parameters, or let's say there are three types of elements. First one is 1D element, second one is shell element or 2D element, which is this one, and third one is our solid element, which is this part. When we mesh the whole part as it is, it will create a 3D element. So for this is a 2D element. For all the previous study we were using 3D element. And now you guys will ask what is 1D element. So when we use weldments in our simulation study, it will simulate it as a 1D element. It So you can convert that part into solid, but mostly it will simulate as 1D element, since it is a complete structure and you don't need to add any thickness to it or any other things. It will create its a solver will create convert the 3D part into the 1D element. I'll show you that. I'll just open another study. Static. Yeah, conveyor frame. Yeah. So we have created this model with the help of weldments, another model in SolidWorks design. So you can see I've used multiple weldment profiles. This one is a square tube. This one is a L bracket. So yeah, SolidWorks will consider the shape of the weldment as well. Let's say you are simulating a study on the square weldment and a L bracket. So you will ask me, when we use 1D element, it will give you the same result for the both of part. No, it won't. You can define the shape and other parameters from it from the simulation study setup, and it will give you the accurate results according to your shape. So for this, so there's another things come in picture called as joints. So wherever the weldment is attached to a body or another weldment, it will create a joint. So see, this part is attached to these two weldments. It has created a joint over here and joint over here. So in this way, SolidWorks simulation create a joint. So for this part, you don't have to add any interactions between the bodies. Let's say you have to calculate all the joints, or you have to define joints. All you have to do is edit joint group. Yeah, and treat as joint for clearance. So what will with the help of this, we can define a joint structure over here. So when we select less than and we add any value over here, all you have to do is select. Let's say we are keeping this as 1 mm, and when we say calculate, the most of the joints will automatically disappear, since they are in 1 meter perimeter of the same joint, or the joint created over here. So it will just remove all those joints for for correctly simulating the geometry. We'll keep it as equal to 0 and we'll just calculate it. So now all of the joints are here. So after treat as after keeping the value for as 1 meter, it has created a single joint for all these other joints. Like this joint has all these two joints are converted into a single joint for this. Yeah. So after calculating, we'll click on OK. So these are joints. So we can check. Yeah. We'll just add fixtures. First of all, I'll add fixtures. So in the you can see there's one more part or one more fixture added to this list, which is immovable. So immovable fixture uh, is only added when a part is 1D element, which is weldments, or 2D element, again, which is sheet metal or shelled element. So to give you exactly what it is, I'll just open this. Okay, this no description over here. So what fixed geometry does, it does that it will constrain all the degrees of freedom of that body. But when you use immovable or no translation, it will constrain only translation degrees of freedom. It won't constrain the rotational degrees of freedom of the body. To give you correct example, just yeah, this is more accurate example. Yeah, sorry. Yeah. So for fixed, it has constrained all the degrees of freedom, like translation as well as rotational. For immovable, it has only constrained the translation degrees of freedom, but it kept the rotational degrees of freedom open. So this is how you can set the or you can add your fixtures according to your need. So for this, we're gonna keep the geometry or keep the fixture as fixed. Now you can see there's a different option. It will show you joints. So in this, you only have to select the joint which needs to be fixed. So for this, I'm just selecting all these joints. Um, so these six are joint. Okay, now I selected this. Yeah, so these six joints are fixed. Previously in 3D modeling or in 2D modeling or 2D elements, we have to select edge, face, or a vertices to fix the geometry. For this, for the elements, it's different. We can fix the geometry, or we can add fixtures on basis of joints as well.